Solubility equilibrium. I'm going to give you the solubility rules again. You've seen them before. If it says soluble, that means it's aqueous, it dissolves in water. If it says insoluble, that means it forms a precipitate in water. Now, even though it says insoluble, these salts will actually dissolve to a slight extent in water. For example, silver chloride, AgCl. If you go back to the solubility rules, it says that is insoluble, it's a solid. It will actually dissolve to a slight extent and produce these ions, Ag plus and Cl minus. And we're going to introduce something called the solubility product constant, Ksp, which is equal to the product of the concentration of the ions. So for this example, Ksp would be equal to the concentration of silver ions times chloride ions. We leave out the solid because the concentration of a solid does not change. So let's look at a couple examples. First, start with our equation. So my solid here is lead 2 sulfide. So that's going to dissociate into lead ions plus sulfide ions. I'm going to assign a value of x for the concentration of PbS, and since the coefficients are 1 to 1 to 1, if PbS is x, lead is x, and sulfide is x. All right, my Ksp expression. Ksp is equal to lead times sulfide, and we leave out the solid because the concentration of a solid does not change. We know the value for Ksp, 3 times 10 to the negative 28th. Lead, we have a value of x. Sulfide is x. So that would be x squared equals 3 times 10 to the negative 28th. I'm trying to solve for the concentration of lead. Well, lead is x. So simply take the square root of 3 times 10 to the negative 28th to get lead concentration. 1.7 times 10 to the negative 14th molar. Let's look at a different example with a different solid. My solid here is calcium fluoride. So write our equation first. Calcium fluoride decomposes into calcium ions plus 2 fluoride. I'm going to assign a value of x for the calcium fluoride. That means calcium is also x, but fluoride, because of the coefficient of 2, is 2x. Write the Ksp expression. Ksp is equal to the concentration of calcium ions times fluoride ions squared, again because of the coefficient. Ksp, 3.9, 10 to the negative 11th, is equal to calcium, which is x, times fluoride, which is 2x, and that is squared. Now 2x squared is actually 4x squared times another x is 4x cubed. I want the concentration of calcium, which is x. So I'm going to take 3.9 times 10 to the negative 11th, divide by 4, and then take the cube root of that number. So make sure you can find that cube root function on your calculator, and you will get calcium ion concentration equal to 2.1 10 to the negative 4th molar. A common ion is an ion that's found in both salts, and a common ion lowers the solubility of an ionic compound. It's known as the common ion effect. Let's look at a couple of those examples. Just like before, I want to write an equation first, starting with my solid. My solid here is silver bromide. AgBr dissociates into Ag plus, Br minus. And we can assign the values for x because the coefficients are 1 to 1. They're all x. The difference here is I'm adding silver nitrate. So I'm adding silver as my common ion. So instead of silver just being x, it's going to be x plus whatever my concentration is, which is 0.02 moles in 1 liter. So plus 0.02 molar. That's the concentration for silver. So when I set up my KSP expression, KSP is going to be equal to silver ion concentration times bromide. KSP we're given 5 times 10 to the negative 13th. Silver is X plus 0.02, and bromide is X. Okay, mathematically this looks like we're going to get into a quadratic, but I would like to avoid the quadratic if we can. X is a really small number, so when I add it to 0.2, it is negligible. We can just get rid of plus X, and that makes the math a lot easier. So get rid of plus X. X is really small compared to 0.02. It's negligible. We're solving for the concentration of bromide, which is just X. All we have to do is take 5 times 10 to the negative 13th and divide by 0.02. So the concentration of bromide, 2.5, 10 to the negative 11th. So a common ion, in this case silver is the common ion, it lowers the solubility of the solid silver bromide. Let's look at one more example with common ion. Start with an equation. My equation is FeS, which is my solid, dissociates into iron ions and sulfide ions. Assign values of X. We're adding a common ion, in this case iron 2 nitrate, so my common ion is iron. So iron is going to be X plus the 0.04 molar, 0.04 moles in 1 liter. KSP is equal to Fe multiplied by sulfide. We know the value, 8 times 10 to the negative 19th. Set that equal to X plus 0.04 for iron, and then sulfide is just X. But just like in the previous problem, we don't want the quadratic. X is so small compared to 0.04, it's negligible. Get rid of it. It'll make the math a lot easier. So all we have to do is take 8 times 10 to the negative 19th, divide by 0.04. That will give me X, which is the concentration of sulfide. So in this case, the concentration of sulfide, 2 times 10 to the negative 17th molar.